Es para mí un placer poder tener el privilegio de dar la presentación de una persona que ha dedicado mucho de su vida al impulso en el área de córnea, tanto en la parte refractiva como de ciencias básicas en el área de investigación de distrofias. La doctora S.Weiss tiene la especialidad de oftalmología en el Instituto Bascom Palmer. Hizo su residencia en patología ocular en el Massachusetts Eye and Ear Infirmary de la Escuela de Medicina de la Universidad de Harvard en Boston. Hizo su residencia en córnea y enfermedades externas oculares en la Universidad de Emory, Atlanta, Georgia. Ha sido profesor visitante en distintas asignaciones de hospitales, entre ellos en Taipei, Taiwán, en la Escuela de Medicina Godfrey Huggins, también de Harare, Zimbabue. Es profesor asociado del Departamento de Oftalmología del Centro Médico de la Universidad de Massachusetts en los años de 1986 a 1995. En ese mismo año se incorporó al Instituto I. Kresge y como profesor de oftalmología en patología y directora de cirugía refractiva. Sus áreas de interés clínico es principalmente en LASIK en pacientes con enfermedades sistémicas, complicaciones de cirugía refractiva, cirugía de catarata, cirugía de córnea, en distrofias corneales y tiene particular interés en la distrofia de Schneider por 18 años que ya ha tenido experiencia en el estudio de la misma y fue quien descubrió el gen causal que participa. Es directora del panel de implantes oculares de la FDA, es directora del curso básico y clínico en cirugía refractiva de la Academia Americana de Oftalmología, que es cuando edita su primer libro, directora del Banco de Ojos también de la Academia Americana de Oftalmología, miembro de la FDA y del Instituto Nacional de Salud. Es directora del Comité Internacional de Clasificación de las Distrofias, que será prácticamente la plática que la doctora nos va a comentar. Es miembro del Comité Editorial de Córnea, de la revista IOPS, de INET. Es revisor de múltiples revistas, entre ellas el Review for Survey of Ophthalmology, de Ophthalmology, del American Journal of Ophthalmology, Current Eye Research, British Journal of Ophthalmology, y entre otras. Así, ha publicado más de 18 artículos como primer autor y tiene una amplia experiencia en el área. Actualmente la doctora S.Weiss es directora de oftalmología de la Universidad del Estado de Luisiana, jefe y profesor del Departamento de Oftalmología y Patología, Dr. Herbert Kaufman, a la fecha, a partir del 2011. Entonces, para mí es un privilegio presentarlas, tiene una gran experiencia y disfrutemos de esta plática que nos va a dar sobre la clasificación actual de las distrofias corneales. Doctora Jane, bienvenida a Cancún, muchas gracias por aceptar.
Thank you for your beautiful introduction, and I want to thank the organizers of the meeting for inviting me. I'd like to speak to you today about the IC3D cornea dystrophy nomenclature. And what is a corneal dystrophy? Well, we usually think of it as something bilateral with a corneal opacity that's hereditary and has no systemic associations. But what is the quality of this definition? For every part of this definition, there's an exception. Is every dystrophy bilateral? No. Posterior polymorphous dystrophy with these railroad track opacifications and blisters on the endothelium can indeed be unilateral, not always bilateral. Is every dystrophy inherited? No. Epithelial map dot dystrophy, where there's excess basement membrane causing dots and map type changes and associated with recurrent epithelial erosion, we know most of these are degenerative, they're not hereditary. Does every dystrophy have the absence of systemic associations? No. And by the way, is the translation working? Okay, bueno. Macular dystrophy is known to have 3 different subtypes based on whether there's antigenic keratin sulfate in the cornea and in the serum. So this has a systemic change associated, as does Schneider's dystrophy, where 2/3 of the patients are known to have hypercholesterolemia, and some patients also have knock-knee or genu valgum. So indeed, every single part of this definition has an exception. Not such a good definition then. So where did we get this name from? Dystrophy, dys means wrong and troph means nourishment. The word was first used in the medical literature in 1884 when Erb used it to describe what came to be known as a muscular dystrophy. It then was used in the ophthalmology literature in 1890 when Gronow first described two patients, one who proved to have what we know as granular dystrophy and one that we know to have macular dystrophy, and he used the word nodulae cornea, and the word dystrophy then caught on for this class of disease starting in 1890. The problem is, in 1890, they didn't have a slit lamp. What did they have? They could describe things. And so we are using a nomenclature system which is derived from before the slit lamp. And in those days, they could only describe it on how it looked or the phenotype and on the histopathology. And some of what we're still using is based on drawings like this. There's a change between 1890 and 2012. We have a lot more information now, and what we have now is the contribution of genetics to our understanding of the corneal dystrophies. For example, we have this patient with granular lattice or Avellino dystrophy, this individual with granular dystrophy, this person with lattice dystrophy, and this person with Reese-Buechler's dystrophy. 4 different names, 4 different dystrophies. Are they different? Maybe not. They all go to the TGFBI gene. Each of these goes to one gene. They look different, but the same gene can give different dystrophies. Some patients with MAP-dot dystrophy are also mapped to this gene, as does Reese-Buechler's, Thiel-Behnke, granular, Avellino, and lattice. Does the opposite occur? Yes, it does. This is a patient with Thiel-Behnke. Thiel-Behnke can map to chromosome 5 or chromosome 10. And I would submit to you, it's not the same disease if it's mapped to 2 different chromosomes. It may look the same, but I don't think it's the same. So do the names matter? I think incorrect nomenclature has clinical implications. It may increase the difficulty of the diagnosis. And this brings me to the dystrophy that I have worked on for a number of years, which had been called Schneider's crystalline corneal dystrophy. Here's a family of patients that was sent to me. These 2 patients had been seen by many doctors, had corneal transplants, and no one could figure out what they had. Of course, they couldn't have Schneider's crystalline corneal dystrophy because they didn't have crystals. But that's not true. We found the gene for this, UBIAD1, a few years ago, and they had the UBIAD1 gene. They had Schneider's crystalline corneal dystrophy. And in fact, in the 90s, I wrote this article because I found that only half of patients with Schneider's crystalline corneal dystrophy had corneal crystals. I came up with this name. None of you have ever heard the name because no one else used it besides me. But nonetheless, some years later, I followed 115 patients with Schneider's. I found that only about half of my patients had crystals, but 93% of patients with other doctors had crystals. It was the same disease, but what was happening is patients with Schneider's without crystals were not being diagnosed because of the name. Schneider crystalline corneal dystrophy. You must have to have crystals, but you don't. So in 2005 at the World Cornea Congress, I found that other doctors were giving presentations having the same type of problem, apologizing things that did not make sense. And it seemed that it was time to fix it. Let's not keep on using something from 1890 and 900 when we're in the year 2000 and we have different knowledge and different techniques. And I knew we needed something with international representation, with the expertise of cornea specialists, geneticists, and pathologists. So we started the IC3D, and the goal was to incorporate the new knowledge and create a nomenclature system that was user-friendly, could be updated, would reflect clinical histopathology and genetic information, and take out what we knew to be wrong. Instead of apologizing, let's just remove it. For example, posterior crocodile shagreen versus central cloudy dystrophy of Francois. This is a patient with posterior crocodile shagreen. This is a patient with central cloudy dystrophy of Francois. I can't tell the difference. Why can't I tell the difference? Because they look the same. What is central cloudy dystrophy of Francois? There were only a few articles with family inheritance, but basically we don't have a chromosome. No one ever looked for one. We don't have a gene. We don't have it that well defined, except for this is how it looks, and that's how posterior crocodile shagreen looks. Is there even a central cloudy dystrophy of Francois? So one thing we wanted to try to do is how could we distinguish things that we knew existed, granular, lattice, and Schneider, from things that were written about years ago. We use the name, but we don't know if it's real. And Gordon Clintworth, who's an excellent ocular pathologist, suggested this type of category system. If something is poorly defined clinically, there's no gene or gene locus, give it a category 4. As it becomes more defined clinically, give it a category 3. Once we know the gene locus, it's a category 2. And once we know the gene, it's a category 1. So as we learn about something, if it's real, it should move up into a category 1. However, if it does not exist, it will remain a category 4, and perhaps at some point we can just eliminate it as something that is not real or a subtype of another known dystrophy, and we've already used the category system in the nomenclature to do that. What does the new nomenclature look like? We tried to make it as familiar as possible so it's easy to use. So it's still anatomically based. There are templates, which I will show you, and there's an appendix of gene and gene mutations. And this was published in Cornea 2008. And what is very easy about it is obtainable on the Cornea Society website. So everyone has access to it. You just go to www.corneasociety.org. And this is the old look of the website. It has been updated. But either way, if you scroll down, I think the mic, okay. If you scroll down, you see the IC3D classification of corneal dystrophies. And if you click on that, the article comes up. And the anatomic classification. So we divide it into epithelial and subepithelial. But for example, for MAP-dot dystrophy, we say most of these are degenerative. They're not inherited, but some of them are on TGFBI. We have some that you may have never seen. This was recently described with some good documentation in Scandinavia. For Bowman, we have Grayson-Wilbrandt. I remember being taught about that. There's only one article. They don't even have a photograph. No one else ever saw it again. Well, maybe after we have this in there for a period of time, if no one ever sees it again, we can eliminate it. And our residents don't have to keep on learning about it. Then under the stromal, we have TGFBI corneal dystrophies, and in this we have lattice and granular, and because we want to start thinking genetically. And we have decimase and endothelial dystrophies. The new nomenclature has what we call templates. What is this? I have worked on, for many years, on the American Academy of Ophthalmology Basic and Clinical Science course series, and I chaired the 13 books for a number of years. So I like to do things so our residents can learn from it, nice, clear, easy, and they can study for their boards. So for example, with Schneider's, we have the name, we have the alternate names, the gene locus, the gene, the inheritance, the onset, the signs. We have a number of photos, and then we have the symptoms, the course, and the pathology, as well as a little explanation. Everything's one page, short and sweet. If you're in your clinic, you don't know what something is, you can click this on, go through the photos, and hopefully figure out. And then, as of 2008, we had the genes and gene mutations for the diseases. Well, the whole question is anyone going to use this? or is it an academic exercise? So I think people are using it. Initially, when we did the article, and with the support of the Cornea Society, this was translated into Spanish, and they recently took the Spanish off the website. I don't know why, and they're going to be putting it back on. It was recently translated into German. It's been referenced by the National Eye Institute, and it's been included in the Cornea book at the Basic and Clinical Science course series for American Academy of Ophthalmology. Just because I chaired that series was probably nothing to do with it. Does this matter? I think it matters. I think developing a scientific language to accurately describe disease entities will allow us to think more clearly, and we can get past the phenotype and get into the genotype to try to make inroads into what causes these problems. And with this in mind, I was fortunate to be able to host a ARVO-Pfizer symposium a few years ago and get together some experts on this. And what was introduced or discussed there was, in the United States, we have something called iGene, where the National Eye Institute has supported sending samples to them for genetic diagnosis of these patients. So this will make inroads into getting past looking at things phenotypically and trying to develop a repository of genetic information on these diseases. I would like to thank the Cornea Society that supported the work, as well as the Mexican Keratorefractive Society for inviting me, and certainly the members of this organization internationally who helped put this new nomenclature system together. Thank you for your attention.